here, um, we're talking about primes. So first of all, I'm going to list some primes. Okay, so we got 10, 2, 3, 5, 7, 11, 13, 17, 19, and we can list on and on and on. But we want to find the fundamental concept. So as you see here, if you don't know what primes are basically numbers that can be only divisible by it in itself. No, by it in one. Sorry, it in one. So as you see here, we have a list of primes, and it's asking what is the sum of the digits. Okay, sum of the digits we can find later of the smallest prime that can be written as 5 distinct primes. So we want to pick 5 distinct primes, and we then want to find this. If we add them up, they should equal a prime number, and we're going to find the smallest prime number that satisfies that condition. So as you see here, so first we're gonna have 3, 5, 7, and the reason why 2 can't be included in the list is because if we have 2 is the only even prime number. If we have 2 right here and then 3, 5, 7, 11, or any other primes that are all odd, that means we will have a even number as a result. Because if we go further in, we have 4. So we have 1 times 2, which is the only even prime number, so that's equal to 2. And if we have 4 times any other prime number, which they're all odd, is even a 2 is the only even prime number. So if we have 4 times an all odd numbers, then we'll have an even result. And you can go test that yourself if you want to. Just like we will always have an even result. If we add even and even, we also get even. And there's no prime number that will be even after that. And 2 does not count. Okay, so we have this right here, and we have 3, 5, 7, and 11 first of all. And the reason why we already know that these 3 prime numbers are basically guaranteed to be included in the list is because we're trying to find the smallest. And obviously, the M&A is probably not that cruel to make you find include larger prime numbers. So we have 3, 5, and 7 already included in the list, and that's equal to 15. And then it's just basically a guess and check for the last 2 prime numbers. And there's not really much guessing and checking to do here because we're trying to find the smallest. Remember, we're trying to find the smallest, and yeah. Okay, so the smallest possible is 11 and 13, but that won't work because 11 plus 13 is equal to 24. 24 plus 15 is equal to 39, and that's not prime because it would be divisible by 3. So we have to include some other variation. And the next smallest is obviously 11 and 17. 11 plus 17 is equal to, we can also switch it around. We can use 13 and 17, but that's not smallest. So the next smallest is 11 and 17, and that is equal to 28. 28 plus the original 15 is equal to 43. And 43 is a prime number, so we can automatically know that that is the smallest case. And we can have obviously different scenarios, but they're not as small. So this is the smallest, 43. But be aware, what is it asking for? What is the sum of the digits of that number? So the smallest prime number, that is the sum of 5 distinct primes, is 43, and the sum of the digits of that prime, which is 43, is 7. So the answer is B.